Let us look at another example of time value of money, where we will see multiple methods of finding out future value of an annuity due. So the problem at hand is, what is the future value of a 5-year annuity due that promises to pay you rupees 300 at the beginning of every year? Assume that all payments are reinvested at 7% a year until year 5. So let us first recall what is an annuity and what is annuity due. So an annuity is a series of equal payments made at fixed intervals for a specified number of periods. Now, if these payments are made at the beginning of each period, then the annuity is an annuity due. Let us now understand this example using a time scale. So the tenure here is 5 years because this is a 5-year annuity. So let's say this is the time scale. So 0, 1, 2, 3, 4, and 5. Now this is an annuity due that promises to pay you rupees 300 at the beginning of every year. So this is the beginning of the first year, so we are getting 300 rupees. Beginning of second year, we are getting 300 rupees. Beginning of third year, we are getting 300 rupees. Beginning of fourth year, again 300, and beginning of fifth year, again 300 rupees. Now once we get these payments from this annuity, we are going to reinvest these at 7% a year until year 5. So this 300 rupees will be invested at a rate of 7% per annum up till year 5. This 300 rupees will also be reinvested up to year 5. This 300 will also be reinvested up to year 5. So basically this 300 becomes an outgoing money from our pocket because these are being reinvested at 7% a year. So let me put a negative sign here indicating that these are outflows from our pocket. And finally, we have to find out what this total comes out to be. So what is the future value after investing all of these at 7% per annum until the 5th year? So let us look at the first method of solving this example, which is using the formula for compounding or discounting. So as we had discussed earlier, this amount of 300 rupees will be invested at 7% per annum up to the 5th year. So basically this 300 rupees will get an interest of 7% for the first year. Then for the second year, again the first year's interest plus the principal will get interest of 7%, and so on. So let's say the final amount that we get at the end of the 5th year for this first installment of 300 rupees is FV1. Similarly, the second installment of 300 rupees will also gain 7% per annum up till the 5th year. Let's say this is FV2. Similarly, we'll have FV3, FV4, and FV5. And all of these, when put together, will give us the future value of the entire annuity. So the future value of the annuity is equal to FV1 plus FV2 plus FV3 plus FV4 plus FV5. Now let's see how to calculate these different future values. So let's first take the case of FV1, which is nothing but this 300 rupees which is being invested at 7% per annum compounded annually for the next 5 years. So this will be 1, 2, 3, 4 and 5 years. So this is a case of compound interest. The formula for compound interest is A is equal to P into 1 plus I to the power n. A is the final amount at the end of the tenure. P is the amount which is being invested at the beginning of the tenure. N is the number of compounding periods and I is the rate of interest per compounding period. So we can rewrite this as future value is equal to present value into 1 plus I to the power n. So in case of FV1, the future value is present value, which is nothing but this 300 rupees. So 300 into 1 plus I is 7% or 0.07 to the power n. N is the number of compounding periods, which is 5 in this case, plus FV2. So same thing. So the present value is 300 because this is the second installment of 300 rupees into bracket 1 plus 0.07 to the power 4 and so on. And then FV5 will be 300 into 1 plus 0.07 to the power 1 because this fifth installment of 300 rupees will be deposited in the bank for 1 year only, where it will gain 7% per annum. So this is equal to 300 into 1.07 to the power 5 plus 300 into 1.07 to the power 4, so on, plus 300 into 1.07 to the power 1. So let's calculate this. So this can also be written as 300. We'll take this as common. 1.07 to the power 5 plus 1.07 to the power 4 plus 1.07 to the power 1. So 1.07 x to the power y of 5 plus 1.07 x to the power y 4 plus 1.07 x to the power y 3 plus 1.07 x to the power y 2 plus 1.07 to the power 1, which is 1.07. So this is 6.15 and we'll multiply this with 300. So we get 1845.987. So let's round it off to 2 decimal. So 1845.99 rupees. Now this method is easy because we just have to remember the formula of compound interest. However, imagine a case where the tenure of the annuity is 20 or 30 or 40 years. In that case, this calculation will become very, very tedious. So let's take a look at the second method, which is to use the formula for finding out the future value of an annuity due. Now in one of the previous videos, we have seen how to derive the formula for finding out the future value of an annuity due. So the formula is future value is equal to A into 1 plus I into bracket 1 plus I to the power n minus 1 divided by I. Now this formula can also be written as future value is equal to future value of an ordinary annuity multiplied by 1 plus I. So let us now plug in the values in this formula. So we get A is 300, 1 plus I is 7 by 100, which is 0.07. So 1 plus 0.07 is 1.07, into bracket again 1 plus I, which is 1.07 to the power n. N here is 5 minus 1 divided by I, which is 0.07. So let's calculate the value for this bracket first. So 1.07 to the power 5, 1.07 to the power 5 minus 1 divided by 0.07 multiplied by 1.07 multiplied by 300. So 1845.987, which can be rounded off to 1845.99. So this is equal to 1845.99 rupees. This is the same answer that we got using the first method. So in the second method, the formula we used was this. So if we take this portion, this basically the compound value factor of an ordinary annuity, and tables have been established for this with standard values of I and N. So we can also write this formula as FV is equal to A into 1 plus I into compound value factor of an annuity, and this annuity, I mean the ordinary annuity. Now some people have also established tables for compound value factor of an annuity due. Those tables consider the value of this portion. So in that case, the formula becomes A into compound value factor of an annuity, in this case annuity due. So for our case, we have the value of N as 5 and I as 7%. So for our example, we'll use the table for compound value factor of an ordinary annuity to calculate the future value of the annuity due. That means we'll use this formula here. So this table represents the compound value factor of an ordinary annuity. The number of periods at hand is 5. The rate of interest is 7%. So we have to take the value at the intersection of these two, which is 5.7507. So let us use this value in our formula. So let us plug in the values in this formula. So A is 300, 1 plus I is 1.07, and CVFA is 5.7507. So let us calculate this value. So 300 into 1.07 into 5.7507. So the answer is 1845.97 rupees. Now let us look at the fourth method, which is to use the financial calculator. Now in order to use the financial calculator to find out the future value of an annuity due, we have to take into consideration 5 main buttons. The first one is N, which is the number of periods, which in our case is 5. Next is I, which is the rate of interest, which is 7% in our case. Now when we use the value for I in the formula, we make it the rate of interest divided by 100. However, while using the financial calculator, we take the rate of interest as is, that is 7. Payment amount, which is nothing but the 300 rupees that we are getting every year. Now for entering these values of payments, we have to consider the sign very carefully. Now in this case, since all these 300 rupee installments are going to be reinvested, that means they are going out of our pocket, I will consider them as negative values. So minus 300. The present value in this case is the payment amount of 300, so we'll consider this as 0. And we have to find the future value of this annuity. So let me pull my calculator here. Now this is the case of annuity due, where the installments or the annuity amount of 300 rupees is being invested at the beginning of the year. So in order to use the financial calculator for annuities due, we have to change the mode to begin, and while in case of the ordinary annuities it is end. So end is by default, but to make it to begin we have to click this button. So we click on begin mode. So this here displays begin, that means this is in the annuities due calculation mode. Now the method to use the financial calculator is to first enter the value and then let the calculator know what that value stands for. So 5, and this is the value of n, then 7, and this is the value of I, 300, change the sign, and this is the value of payments, 0, which is the value of present value, and now we have to find the future value. So we'll simply click FV. So the future value is equal to 1845.99 rupees, and this is positive because this is the amount that we'll get at the end of the tenure. So these are the 4 methods that can be used to find out the future value of an annuity due.